everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're unpacking the recent Cloudflare outage that happened on December the 5th. We'll also discuss an outage at Venmo and the latest global outage numbers. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Cloudflare experienced an outage lasting about 25 minutes on December the 5th. What happened? And what did the monitoring data tell you?
So the root cause of this was a configuration change. Now, Cloudflare was addressing a security vulnerability, and they were looking to increase the buffer size on their web application firewall. Now, the buffer size are used for analyzing the HTTP request bodies. During the rollout, they noticed that their internal testing tool wasn't actually supporting this larger buffer size and was starting to throw errors. As this tool had no effect on the customer traffic, they thought they'd disable it so they could actually continue with this configuration service. So what that did was expose a latent code bug. And once triggered, it actually caused the edge infrastructure to fail all incoming requests and return these HTTP 500 errors. Now, this was instant and it was global. Services utilizing this service actually went from working to completely unavailable. And then when it actually came back, it sort of came back in a sharp transition. So it wasn't this gradual degradation that we'd actually seen. So this binary failure tells us that we weren't looking at anything regional and we're looking sort of something fundamentally within the service itself. What we also saw was the error. So this 500 error, if we were actually looking at how the page loaded, we actually saw the error come back really quickly. It was coming back in a matter of milliseconds. That also tells us something that's happening. So if we're looking for something, even if it's some sort of back-end service issue, we have this extended time. But the fact it was coming back in 20, 30 milliseconds, depending on which service it's actually going to, told us again that this was actually failing before it got too far into that process. So before they're executing something very heavy in that back end. At the same time, when we're actually looking at the network connections, we actually saw that the service itself returning the 500 errors, but the network fundamentals, so loss rate, being able to sort of resolve the name and that general connectivity and reachability was fine. This actually told us where the issues lay rather than sort of looking at sort of how it's manifesting itself. So the other thing for this was then the network stayed healthy throughout there. So while the applications or the service was actually returning the errors, when we looked at the network fundamentals, so the routing, the DNS, the connectivity, the loss rate across there, we actually saw no issues itself. So we'd already seen from these 500 errors that we were looking at something from a service perspective. That was just able to confirm there was nothing systemic wrong at that network level.
We also saw another Cloudflare outage on November the 18th. What differences did you see between these two incidents?
The November the 18th appeared to show an intermittent pattern. And what I mean by that was it wasn't necessarily that it was this lights on, lights off type of situation. We were seeing some requests which appeared to be getting through. So we sort of saw this intermittent pattern. And it was going in waves where we sort of come up from there. And what that actually turned out to be was it was tied to this file refresh. So it was a file cycle that was occurring every 5 minutes. And then this kind of matched up in this pattern of where we're seeing with some requests getting through, some not getting through. But it was, again, still this global. Whereas when we looked at the December the 5th outage, this was this lights on, lights off. So it was the same error coming back. We're seeing 500 internal server errors coming back there. But the way it was manifesting itself in terms of how it's impacting was completely different. So it sort of told us what was going on there as well. So again, we're tied to the back end. But this pattern of complete failure said, all right, this is something fundamental. And we had this global issue. Whereas the other one started to try and look what was happening. And there were sort of multiple things involved in that process.
We've talked in the past about how you shouldn't just rely on error messages to diagnose a fault. And here's a great example of it, right? Because you've got two faults showing HTTP 500 errors, and yet they're very different in nature.
Yeah, exactly. You have to look at everything in context. So we have to be able to understand what it is. And this is where you want to take those other signals into consideration. So straight away, the 500 is telling us we're looking at something from the back end. But then what is it? What services is it actually impacting? This is telling us we're getting to this front door and we're unable to get the back end service. There's lots of things that could be happening with that 500 error. Is it a consistent one? This lights on, lights off situation? Or do we have this where some are getting through, some aren't getting through? Because again, this starts to tell you all different characteristics. But it really is that combination of signals, looking at this service holistically. And remember, we're actually considering services here. We're not looking at individual components. We're looking at everything together.
Cloudflare announced system hardening measures after November the 18th. What can we learn from the fact that we saw another global incident only 3 weeks later?
Cloudflare did explicitly state in the December the 5th post-incident review that the resilience work they announced on November the 18th remains their first priority across the organisation, but they hadn't actually yet finished deploying them yet. So the short answer to that is these incidents happened before all the changes were actually in place. But the other thing for there is we need to consider is that these different failure modes reveal this broader challenge, right? So the November the 8th was a configuration file that exceeded hard code limits, essentially a capacity issue that we faced there. Whereas December the 5th was this latent code bug, which was triggered by disabling this test tool. So as we said, these are fundamentally different types of failures, showing that there isn't necessarily one specific problem, but we're looking to sort of address the overall architecture itself. The other aspect of this is the recovery time. So the December the 5th resolved in around 25 minutes because this was effectively a rollback configuration. When they identified what was going on, they were able just to roll back the configuration and resolve the fix. Undoing the change then allowed it to propagate quicker and get things back online there. The November the 18th one sort of took 5.5 hours because it actually required fixing the configuration generation logic, stopping this bad configuration being propagated and then forcing the proxy restart itself. So the faster resolution wasn't necessarily better detection or they were able to identify it there. It was because effectively it was simpler to fix. There was only one element they needed to fix. Whereas when we were looking at the other one, we needed to fix different things to actually get to that point, which comes back to this identifying all those signals together and looking at everything we've got.
Payments provider Venmo experienced an outage for several hours on December the 3rd. Based on your analysis, what appeared to happen here?
So we observed a drop in availability. Now, this manifested as HTTP 503 service unavailable errors. But similar to the Cloudflare, all the network fundamentals looked fine. So there was no packet loss, no routing issues, no essential connectivity problems to the service itself. That immediately tells us we're not looking at a network issue. And it's actually something with that application infrastructure. As we said, we saw the 503 errors. Now, this was a different error signature than the Cloudflare. So again, we say the 500 error is something that tells us we're getting something back from the server. So a 500 is going to suggest there's something broken in the code or the logic itself, whereas a 503 typically indicates some sort of back-end service issue where it can't handle the request. Now, this could be capacity, it could be something like rate limiting, or it could be something several layers deep in the application stack itself that's actually failing.
You mentioned different error codes, 500s for Cloudflare, 503s for Venmo. Why does that distinction matter for diagnosing these kinds of incidents?
So different errors point to different failure modes. As we said, a 500 means something broke internally on the server side. So this could be code, could be configuration, could be resources, really a number of things. But effectively what it's telling me is there's an internal service error. I actually can't get that service to function. Whereas when we look at a 503, it's actually telling us that the service can't handle the request right now. So this could be something to do with capacity. It could be some sort of rate limiting, or it could be some sort of back-end dependency where we actually can't get to that system. It's unavailable right now. We know it is, but it's unavailable. So it's actually up as opposed to its complete failure. This changes then how we approach the diagnosis. So with 500s, we're looking at what went wrong with internal processing. With the 503s, we're thinking about how is that reaching that back-end service. So thinking about the capacity. What part of the delivery chain might be overwhelmed or unavailable. So these are different starting points for the investigation of where we actually need to look. But the error codes, as we said, are just the starting point. They tell you the symptom is at the application layer. We know where it is. But to see that full picture, you really need to rule out other things. So you really need to rule out the network health. Where are we actually going to? Are we going to the correct destination? Is it the proxy itself or the CDN that's actually returning that type of error there? And this is why you really need that holistic perspective. I need to be able to understand what's going across there. So in this particular case, we could see the network paths were healthy. We could see we were getting these application errors. We weren't then looking at that network conditions. We could isolate the fault domain where we actually need to drill down and actually look and start that investigation. Now, why that becomes important is because once you've identified that fault domain, it enables you to understand what mitigation steps I need to take. So by identifying where the fault is, you can rule things in, rule things out, but also understand the processes you need to do to get around it. This may then be some automated process, or it may be that what we're going to do is to switch what we're doing from providers or switch services we're actually using to sort of put all these things together.
When you're dealing with a payment provider, a lack of service may mean you can't send or receive money. From a consumer's point of view, it's important to have a fallback option here, right?
So in theory, yes, but in practice, it's actually more complicated. Now, you could have multiple payment apps You could keep cash, you can maintain traditional bank accounts, but people have consolidated this digital first solutions because they're more convenient. So the fallback's going to require sort of deliberate preparation. And this comes back to sort of where the failure occurs, because this is what mitigation steps you're actually going to do. If it's Venmo's own application layer, then they could potentially have redundancy or failover themselves. But if it's in a cloud provider, like Venmo experienced in October with an AWS outage in US East 1, then that's something sort of different, or authentication services, or some back-end payment processing rails. All of these they depend on, but they don't actually control. Then that fallback becomes an architectural question you need to solve in advance. So from the outside, you just see Venmo is down, right? But the mitigations depends on which dependency actually failed, to which actually steps you need to take and where you're actually going to go to from there. So this represents then some sort of fundamental shift. Whereas beforehand we had these alternatives, you had cash, you had checks themselves, you even had a phone-based system, or you could person transactions. Now the payment apps are the primary transaction method, and maintaining parallel systems requires an intentional effort themselves. So the dependency architecture itself actually amplifies why the fallback matters. These services layer on top of cloud infrastructure, on databases, authentication providers. So when any layer fails, the whole service itself could become unavailable. So without alternative understanding specifically where it is, you have no recourse. You just know you can't access your money with no visibility into which layer failed or when it's going to be fixed. So if you can actually understand that dependency chain where it is, again, we're looking specifically at Venmo here. If I'm taking this to a broader enterprise perspective, I understand where it is within that service delivery chain. I know which processes or steps or mitigation I can actually put in place.
This recent flurry of outages makes it feel like outages are becoming more and more common. Is that actually the case?
It actually seems that way, but if we actually look at the internet's core infrastructure, it remains resilient. It is resilient by design. We have routing protocols, we have these different DNS resolvers, DNS providers, and then the ability to sort of switch around failures itself. So everything works as it was. So the fundamental architecture that makes the internet work is robust, and that hasn't changed. Now, what has changed is how we build on top of it. So we've shifted from distributed independent services to these layered dependencies on shared infrastructure, CDNs, authentication providers, payment processors, cloud platforms. When these foundational layers fail, it doesn't just impact that one service. It impacts hundreds of thousands of dependent services, and they all fail simultaneously. So it's not that they're more frequent, it's just that they're more consequential. Individual failures aren't necessarily happening more often, but the blast radius has grown. So a single CDN issue can affect hundreds of customer applications. A cloud region problem can take entire swathes of services offline. So the impact propagates through these dependency chains themselves. And there's essentially no fallback channel anymore. Decades ago, we had paper systems, we have phone-based alternatives, manual processes. But today's digital infrastructure is often the only operational challenge. So when it fails, operations stop completely. And that makes these individual incidents feel more severe because they are to a degree. There's less margin for error.
Thanks for the deep dive into those outages, Mike. And now let's turn to the overall outage trends and what we've seen in the past fortnight.
So we actually saw increases over the 2-week period. So from December the 1st to December the 7th, we observed 205 global outages. This is a 77% jump from the 116 we saw the prior week. Then December the 8th to the 14th, we saw another 78% increase to 364. Now, in the US specifically, it went from 51 to 84 to 188 over that same period. So again, we saw this consistent increase. So these patterns suggest seasonal factors. We tend to see upticks during this time of the year as organizations push before year end. So maintenance windows get compressed and there's generally more activity in the infrastructure. The US represented nearly half the global outages during that December the 1st to December the 14th period, where they accounted for 48% of all the observed network outages. So this is consistent with the patterns we've actually seen before and sort of growing throughout the year, where they've sort of maintained 40% or more.
Talking of seasonal patterns, as we come into the holiday season in many parts of the world, what do you expect to see happen over the next few weeks?
What typically happens this time of year is we've compressed these maintenance windows, we start to get all this stuff, and then we see a period of time where we actually drop off again. What then follows is when we start to get into January, when everything starts to come back online, we then see not a backlog as such, but then all of a sudden this maintenance work starts and you start to see increases in outages again. And what I should say is that a lot of these, when we actually look at these outages, they're not necessarily user impacting themselves. So they're sort of short duration, or they look like they're maintenance, they're done sort of outside of business hours themselves. So again, typically what we've seen is this rise as we come out into the January window. So it'll be interesting to see if that happens again this year.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this help ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions or feedback to internetreport@thousandeyes.com. Until next time, goodbye.